I'm going to tell you a secret most people don't know. Your street isn't just a place for cars or bikes. It's a water machine. Beneath the asphalt, your city is quietly deciding whether rain becomes floods, pollution, or cool shade. Right now, most people think drains make water go away. But that's the problem. When 1 centimeter of rain falls on just 1 square kilometer of city, that's 10,000 square meters of water, enough to fill 4 Olympic pools rushed into pipes in minutes. Water-sensitive urban design flips the script. It treats rain as a resource, not a waste, and redesigns streets, roofs, and parks to slow, soak, clean, store, and share water right where it falls. Water-sensitive urban design is a planning and design approach that manages the entire urban water cycle: stormwater, groundwater, drinking water, and wastewater as one connected system. The goal is to design places that reduce flood peaks, recharge aquifers, save potable water, and cool cities while creating livable streets. In other words, quantity, quality, amenity, and resilience all in one playbook. You'll also hear related terms: LID or Low Impact Development, SUDS or Sustainable Drainage Systems, and Green-Blue Infrastructure. Different names, same core idea: treat rain at the source and close the loop. Cities are covered by impervious surfaces, roofs, asphalt, and concrete. As those surfaces climb past 40 to 60% in a neighborhood, runoff volumes can jump 2 to 8 times compared to natural land. That means faster flows, higher flood peaks, and more pollutants including oil, metals, and microplastics flushed into rivers. Add the urban heat island. Hard surfaces can be 5 to 7 degrees Celsius hotter than green areas, and you can get the flood and heat double punch. Meanwhile, many cities still irrigate landscapes with drinking water while dumping stormwater to the sea. WSUD attacks all of that at once. Slow it, soak it, clean it, reuse it, and cool with it. Source control. Handle water where it falls, on roofs, courtyards, and verges. Slow. Flatten hydrographs by delaying peak flows. Spread. Disperse water across multiple small elements, not one mega drain. Soak. Infiltrate into soil to recharge groundwater and irrigate plants. Store. Hold water in cisterns, tanks, and ponds for later use. And safety release. Discharge the remainder without overwhelming pipes or streams. Green roof systems. Vegetated layers on rooftops retain 50 to 80% of annual rainfall, reducing heat flux and extend roof life. Permeable pavements. Porous asphalt, previous concrete, and modular pavers let water pass through to a storage layer, reducing runoff and splash. Bioretention and rain gardens. Shallow planted basins with engineered soil filter pollutants, cut peak flows, and water street trees. Bias wales and tree trenches. Linear soil-based systems along curbs capture curb flow, infiltrate, and irrigate roots. Detention and retention basins. Detention holds then releases. Retention holds for longer or filtrates. Both shave peak flow. Open channels and daylighted conveyance. Shallow channels move water visibly, improving safety, inspection, and education. Rainwater harvesting. Tanks sized to roof area and designed storms feed toilets, irrigation, or cooling, saving potable water. Smart controls. Sensors and valves pre-drain storage before storms and optimize releases afterward. Soil rebuilding. Loamy uncompacted soil with organic matter restores infiltration and root health. For water-sensitive urban design, there are some important steps to consider, including 1. Set targets. For example, retain the first 10 to 20 millimeters of rainfall on site, often 80 to 90% of annual events. 2. Peak storms. Choose design storms intensities, for example 1 in 5 years for conveyance and larger events for safe overflow. 3. Balance flows. Use hydrologic models to match pre-development runoff and cut peak discharge by 30 to 60%. 4. Pollutant reduction. Target total suspended solids removal of 70 to 90%, include nutrient and metal capture where needed. 5. Thermal and heat goals. Shade, evapotranspiration, and water features to lower local surface temperatures by 1 to 3 degrees Celsius. 6. Redundancy and overflow. Always design overtopping paths that don't damage buildings and endanger people. Think complete streets but for water. Narrower travel lanes mean less pavement and runoff. Curb cuts feed planted strips instead of storm drains. Traffic calming islands double as bioretention. Permeable parking lanes create a continuous sponge under the sidewalk. Bike corridors can become green corridors, with swales acting as buffers. Stations and stops integrate rain canopies plus storage tanks to power misters or irrigation. The result? Safer crossings, cooler microclimates, and fewer puddles at the corner you always hop over. Urban runoff carries total suspended solids, nutrients, hydrocarbons, metals, and microplastics. WSUD uses pretreatment, sumps and forebays to settle grit, bioretention media to absorb metals and bind phosphorus, vegetation to uptake nutrients and boost microbial breakdown, and filter strips to slow sheet flow before infiltration. A well-designed train of measures can remove 70 to 90% of sediment, 50 to 80% of metals, and 30 to 70% of nutrients, cutting algal blooms and improving clarity. The hydrograph is your enemy. Peak shaving matters more than average volume. WSUD spreads storage in many small elements, roofs, planters, and trenches, so inflows reach pipes later and weaker. Shaving 15 to 30 minutes off the peak arrival can be the difference between roads staying open or closing. Combined sewer systems benefit too. Fewer surges, fewer combined sewer overflows, and cleaner waterways. Evapotranspiration from vegetation plus evaporative cooling from stored water can drop local temps by 1 to 2 degrees Celsius and surface temps by 5 to 10 degrees Celsius. Shade trees intercept thousands of liters annually. Water-fed greenery stays cooler during the heat waves, protects vulnerable residents, and improves walkability. This is why WSUD belongs in the public realm. Cooler sidewalks keep cities moving when temps spike. Cities and regions can hardwire WSUD into codes and standards, require on-site retention of the first flush, set maximum discharge rates, stormwater fees, charged by impervious area, discount properties with WSUD features, developer incentives, bonus floor area or faster permits for meeting performance targets, funding, use green bonds, utility fees, or resilience funds for public retrofits. Operations, assign maintenance to utilities or certified contractors, create inspection schedules, and asset registries. The key is performance-based rules, reward outcomes, not just checklists. WSUD fails without maintenance. Plan for sediment removal from forebays and inlets, mulch refresh and vegetarian pruning for infiltration and visibility, vacuum sweeping for permeable pavements to keep pores open, mosquito control via design, no stagnant pockets, and proper slopes, safety sightlines for pedestrians and drivers. Done right, WSUD upgrades air quality, shade, cooling, and flood safety in places that need it most. That requires equity mapping, overlay heat, flood risk, and income to prioritize investments. Design for universal access, stable walking services, clear crossing, and lighting. Use co-design so residents help choose plant palettes, seating, and education signs. The result is not just infrastructure, it's public life. Track a tight set of indicators: runoff retention, millimeter per event per year; peak flow reduction, percentage versus baseline; pollutant removal, total suspended solids, nutrients, hydrocarbons, and metals; canopy cover and surface temperature changes; potable water saved, life cycle cost versus gray alternatives; user experience, survey on comfort and walkability. Monitoring isn't busy work, it's how WSUD earns upgrades, not cutbacks. And this is where it gets fun. Mobility corridors are perfect WSUD sponges. Curbside rain gardens buffer bike lanes from traffic. Raised crossings double as mini detention with permeable pavers. Transit stops capture roof runoff into planters that shade queues. Depave underused parking and replace with permeable stalls and trees. Tree trench networks link blocks underground, balancing water between dry and wet spots. Design the street once and it moves people and water better for decades. Here I summarize the most important misconceptions for you. It's just landscaping. No, WSUD is hydrology plus ecology plus urban design with targets and math. Too expensive. Consider life cycle costs and avoid flood damages. Distributed systems often win. It won't work in dense areas. Microsystems in roofs, courtyards, and verges add up. It causes mosquitoes. Good gardening and flow defeat stagnation. It steals parking. Permeable or shared use designs keep capacity while cutting runoff. When starting to design and plan WSUD, the following considerations should be part of the plan. Baseline: map impervious cover, soils, and existing drainage. Targets: set evidence-based retention in millimeters, peak flow in percentage, and pollutants reductions. Concept: place WSUD layers at roof, street, block, and catchment. Sizing: match storage volumes to rainfall statistics and flow rates. Safety: define overload routes and traffic sightlines. Materials: specify media mixes, geotextiles, and rootable volumes for trees. Delivery: stage construction to protect soils from compaction. O&M plan: rules, frequencies, budgets, and training. Monitor and adapt: use data to tweak controls over the first 2 to 3 years. Expect more digital twins, AI-controlled valves, modular bioretention, and water-positive buildings. Streets will be judged not just by level of service for cars, but by level of service for water, how well they absorb, cool, and clean. If you're studying or starting out, WSUD is a future-proof skill that blends climate adaptation, public realm design, and infrastructure. I have provided a quick cheat sheet for you here. Goal: keep the first 10 to 25 millimeters on site. Stack: roofs plus planters plus permeable pavements plus tree trenches. Design for quantity, quality, cooling, amenity, and equity. Prove: peak shaving, pollutant cuts, and heat reduction. Maintain: sweep, prune, refresh media, and inspect inlets. Message: trees are water machines. Design them like it. Look at your block after the next rain. Do you see rivers in the gutter or gardens drinking? That's the difference between old drainage and water-sensitive urban design. If you want fewer floods, cooler summers, cleaner rivers, and better streets, push for WSUD in codes, campuses, parking lots, and transport corridors. Remember the secret: a street can be just asphalt or a climate-ready water system disguised as a place to walk, ride, and live.